Hello, Mr. Berry's geometry class. I'm looking at probability intro problems. It was posted on the 12th yesterday, but it is due the 15th. It's not due till Thursday. So here we go. Taking a look at this first problem. Use the spinner to find each theoretical probability. I'm going to at least do half of these for you. The odd ones, and go ahead and try the even ones on your own. You can pause this as necessary, and if you're making mistakes, don't worry about it, correct them, and that's the learning process right there. So for number one, the probability of an even number, so even numbers, we have 2, 4, 6, 8. So we would have 4 out of 8, or 1/2 equals 50%. 3, a prime number. So a prime number, there's a little bit of a, question about whether 1 is a prime number or not, and it is not. So we just have 2, 3, 5, and 7. So that, once again, is 4 out of 8, or 1/2 equals 50%. I'm not sure if you have to go to percentages, but I did. So if you don't have to, then don't go that far. We didn't have to do 4, 5, and 6. Number 7, a baseball player got hit 17 times, got a hit 17 times of his last 64 at bat. What is the experimental probability that the player got a hit? So 19 out of 64, and it would be 29.7%. So if the player comes up to bat 200 times in the season, about how many hits is he likely to get? Well, I took 29.7% of 200, or that becomes how I did that, 0.297. I just changed it to a decimal only by moving the decimal 2 places to the left, and I hit times 200, and that's how I got the 59. About 59 times. He'll if he sticks with that percentage of hitting. Number 9, looking at the Mississippi, and there are 11 letters in Mississippi, so it's the probability of picking an M. If we were to, cut up those letters and like put them in a hat and just draw them randomly, it would be 1 out of 11, or 9%. 11. Probability of picking an S, that would be 4 out of 11, or 36.4%. Not picking an M, so not picking an M would be 10 out of 11, or 90.1%. How I'm finding these percentages, remember, you just treat this as a division problem, so 10 divided by 11, that's how I get that. 15, not an S. So not an S is going to be 7. There's 7 that are not an S, 7 out of 11, and that's 63.6%. Now, 17, suppose you flip 3 coins. What is the theoretical probability of getting at least 2 heads? Well, I have the 3 coins here, and, 2 heads would be this, so that would be 2 out of the 6, 2 out of the 6, or 1/3. Is what I have, or that would be 33%. Although your book answer does have 4/8 or 1/2, but I would argue with that. They said just at least 2. I would say half if they wanted to get heads each time. That would be 3 out of the 6. But as I said, at least 2, so 2 out of the 6 possibilities is what I'm going with. So that's what I have for 17. So good luck with the rest, and hopefully this was helpful to you.